Guys, how are you all? Welcome back. Welcome to Vedantu's JEE channel, everyone. A shout out to all the students who are moving from 11th standard to 12th standard. So, guys, this is the specific time when we all meet at 9 p.m. every day to discuss theory which is related to our JEE preparation. Okay, so today is the day for physics, and I'm back with another topic. We are continuing with the chapter of current electricity, and today one very easy but yet very interesting topic of all the students for all the students, and that is series and parallel combination of resistance. Okay, so before this we have obviously studied about the Ohm's law, okay, and the basics of the understanding of current electricity. So now today we'll be discussing series and parallel combination of resistances, and we'll solve a lot of problems based upon the same. Okay guys, so let's go forward. For all of those who are new on the channel and do not know me, let me start off with my introduction. Okay, so guys, this is me, your Suri sir, and I'm an alumnus of IIT Bombay. But more importantly, now I'm known as Mugambo on this channel because when you will crack this examination of JEE, Mugambo Khush Hoga. Okay. Apart from that, let me also tell you the schedule that we follow for JEE 2021 aspirants. As I told you, every day at 9 o'clock we meet. So 9 p.m. we meet for theory discussion of physics, chemistry and maths, and 8 p.m. on certain days which are Monday, Wednesday and Thursday we meet for MCQs discussion. Okay. Also, let me introduce you all to your teachers. This is Harsh sir. He teaches you chemistry. This is Arvind sir. He teaches you mathematics. And yes, this is me. I try to teach you all physics. Okay. Awesome. Also, if you are new on the channel, then definitely subscribe to this channel. Okay, guys. And also press the bell icon so that whenever your Suri sir is coming live, you get the notification. Okay. Now, before we move forward, because there are students who are about to appear for JEE examination in the month of July 2020. So guys, if there is any chapter that is left also for 2021 students, that means 12th standard students, if there is any chapter which is not very strong for you from 11th standard, then I have something which I want to share with you all, and that is the micro courses at Vedantu's platform. Okay, so if you are interested, you can use the link in the description of this video. You'll find the link for micro courses. Good news is all the micro courses are now available at just rupee 1. Okay, so you can study any chapter from any subject, physics, chemistry, maths or biology for that matter, from all of these micro courses. Pick your chapter, strengthen it, and be ready for your JEE examination. Okay, so I hope all of you are ready. Let's start with our discussion for the day, and that is about series and parallel combinations. Okay, so first thing first, let's talk about series combination here. I'm sure you are not completely unfamiliar with this topic. Okay, you know that if there are n number of resistors, say in this case I have used three resistances R1, R2, and R3. They are connected in this manner that their combination is connected to a battery of voltage V. Then by talking about combination, what we are intending to do is to replace these three resistors by a single resistance, okay, which will do the same job as it is done by these three resistances. Okay, so in the series combination, what will happen that say if some current I is started from the battery or is being established by the battery here, then the same current will flow through all the resistance. Okay, so in series, remember the current remains same across all the resistance which are there in the same branch. Okay, but if resistances are different, current is same, then the value of the voltage which is going to get dropped, the potential which is going to get dropped as per the Ohm's law, be equal to IR. I is same but R is not the same, most probably. So you will have V1, V2 and V3 as the potential drop which is happening on the individual resistances, and their combination V1 plus V2 plus V3 is going to be the total potential drop which is happening, and that will be equal to the potential that is applied by the battery over here. Okay guys, so in this case, if we want to find out the equivalent resistance which will have the same value of the current flowing through it when it is connected to the same battery, then this is the equivalent diagram, you can say. Okay, RS is the equivalent resistance, I is the current that is flowing through it when the same battery is connected. Okay, So our job is to find out how much will be the value of the series resistance in terms of R1, R2 and R3. Okay. So if I say that the potential drop across the three resistances is overall equal to V and is given by V1 plus V2 plus V3, then if I use the Ohm's law, I can say that V should be equal to I R equivalent, and because the same current is flowing through all the three resistances, it will be I R1 plus I R2 plus I R3. So from here, if you take I common, you get the equivalent resistance as simply R1 plus R2 plus R3. Okay, I'm sure that most of you are aware about this as well. Okay, so if you have say two resistances, okay, then for R1 equal to R2 equal to R, okay, only for two resistance I'm talking about. In that case, your R equivalent is going to be R plus R, that is 2R, which means what, guys? In such combination, when you have multiple resistances, the value of equivalent resistance is going to be greater than the greatest resistance which is there. Okay, greatest value of R that you chose over here in R1, R2 and R3, the equivalent resistance is going to have a value of equivalent resistance which is going to be more than the maximum possible resistance which was there in the combination over there. Okay, so overall, if there are n such resistances, then the equivalent resistance is going to come out to be nr. Okay, R1 plus R2 plus R3. If you have equivalent resistance for n equal resistances, then R plus R plus R plus R is going to give you nr. That means something which can be expressed from here as an extension. Okay, so this is as simple as that is the situation of resistance in terms of series combination. Now, when we speak about parallel combinations, guys, this is how the typical circuit of parallel combination will look like. And here, if the battery which is connected has potential or EMF of V, then that's the same potential which will come across all the branches which are connected in parallel. Okay, that's why the potential drop on R1, R2, and R3 is going to be same. But if we follow the Kirchhoff's laws, okay, which we are going to see very soon, okay, and we have seen something like that in electrostatics before. So if we look at this point where the current I is flowing and started from the battery, then it gets split into I1, I2 and I3. Okay, so definitely the value of current is not going to be same across all the resistances. So if you want to find out the equivalent resistance in this case, which will connect to the same battery and will draw the same value of potential. Okay, say the value of the equivalent resistance is Rp, it's going to draw the same current from the same battery. Okay, so in this case we can say that the current which is flowing in the circuit is I, and through all the individual resistances is I1 plus I2 plus I3. Okay, so we can say that from Ohm's law, V equal to IR, I can be written as V by R. So this is V by R equivalent, which will be equal to V by R1 because potential is same across all the resistances. So I'm writing all the values of I1, I2 and I3 individually as V by R1 plus V by R2 plus V by R3. So if you cancel out V, what you get as the equivalent resistance is the reciprocal addition of all the resistances which were connected in parallel. Okay, so no number matters here. As many resistances are there, you will just keep on putting them as 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. Okay, so from here you can say that Rp is going to be smaller than the least resistance in this case. That means what? Unlike the case of series combination, here the equivalent resistance value will come out to be even smaller than the smallest resistance of the parent combination which was there. Also, if you have two resistances, say R1 and R2, and they are equal, then 1 upon Rp is going to be 1 upon R plus 1 upon R, which is 2 by R. So R equivalent is going to be half of the individual resistance. And on the same lines, if you have n resistances like that, you will write it as R by n. Okay, guys, I hope things are clear now. So here the resistances will be added as 1 upon R1 plus 1 upon R2 plus 1 upon R3 with same value of potential on all the resistances. Same potential drops happens on the equivalent resistance as well. Okay, now time to move to the problem solving. And by problem solving, what reminds me is a quiz which happens every day on Vedantu's platform. Okay, so guys, if you're interested in this quiz, this happens every day at 7 p.m. on Vedantu's app. And why it is interesting is because it is a usually general knowledge quiz, and it goes live at 7 o'clock usually, but you can stay tuned. And why it is also exciting is because there are a lot of prizes to be won, a lot of prize money at stake to be won over there. Okay, so how can you participate? All you have to do is go on the App Store or Play Store of your mobile phone, update your Vedantu app. If you do not have the app, then what are you doing, guys? Come on, download the app right now and be ready for this quiz happening every day. Okay, now time to move and solve questions on series and parallel combination here. Okay, yeah, you can see me touching my specs again and again. I'm new and getting used to this. Okay, so guys, very first question, it says we have to find out the equivalent resistance between A and B. So you can see that this is how from A and B the battery is going to get connected eventually. So this will be one end of the battery, this will be other end of the battery, and you can see that the upper branch is making all the resistances in series. So if this point is A, this point is also going to be A, and all such points where nothing is being connected in between, they will have the same value of potential. So the upper branch is A and B, and the lower branch is also A and B. So 3 and 1 are connected in series. You can see that. Okay. So we can say that 3 and 1 when they'll be connected in series. So R1 plus R2 is going to be the equivalent resistance for the upper branch. So overall, 3 plus 1 is going to become 4. This is 4 ohms, and lower branch is 2 ohms. Okay, so now you have two resistances 4 and 2 connected in parallel. So RAB is going to be R1 R2 upon R1 plus R2. How do we get that in parallel combination? Is because if I have 1 upon RP as 1 upon R1 plus 1 upon R2, when you will simplify this, it will look like R1 R2 upon R1 plus R2. Okay, so this is 4 into 2 upon 4 plus 2, that is 6. So RAB comes out to be 4 by 3 ohms as the equivalent resistance between the 2 points A and B. Okay, cool. On the same lines, try to solve this along with me. You will be able to get this very easily. So you have this and this end going to the battery. Okay, and you can see that the upper branch and the lower branch are connected in parallel. So what you see here, that these two resistances are connected in series. So when you try to draw the equivalent of the upper branch, it tells you that 3 plus 3 is going to be 6 ohms, and lower branch is 3 ohms. So now what you see, that two resistances between A and B are connected in parallel, just much like the previous question only. So RAB can be found as R1 R2 upon R1 plus R2. Okay, or you can go by that 1 upon R1 plus 1 upon R2 as well, not a problem. If you want, I can try that for you. So 1 upon RAB is going to be 1 upon R1, that is 1 upon 6, and 1 upon R2, that is 1 upon 3. Just that with two resistance it gets easier if you go by R1 R2 upon R1 plus R2. Okay, so this says that this is going to be 1 plus 2 by 6, or simply 3 by 6, or 1 by 2. So RAB comes out to be 2 ohms. You can try using this also, you will get the same answer as 2 ohms. Okay, cool. Okay, next one, guys. Here we have to find out the current from the battery as per the same circuit. You can see that the circuit looks similar, so equivalent resistance we already know, and now we have a 3-volt battery connected. This is a question which came in an examination in 2013. So if I want to find out the total current, that will be equal to I equal to V by R equivalent. So the potential drop applied is 3 volts, and R equivalent you found as 2 ohms. That means what? I comes out to be 1.5 ampere. As simple as that. Okay, so the answer is option B. Okay, cool. Moving on to the next one, we have this arrangement given, and again we have to find out the equivalent resistance between point A and point B. Okay, so here we have say this point is A, so I can call this point as C and this point is B. So This point is also C, this is also C, this is B, and this is B. So 3 ohm and 6 ohm, they are connected in parallel. So we'll have to find out their equivalent. Okay. So how will you find R between C and B is R1 R2 upon R1 plus R2. So that is 3 into 6 upon 3 plus 6, that is 9. Simplify. So 3 by 9 is going to simplify like this, and the value of equivalent comes out to be 2 ohms. That means if I simplify this diagram that is given to us, so this is A, this is 4 ohms, this came out to be 2 ohms, and this is B. By the way, the equivalent of 3 and 6 we just now found also in the previous question. So now, very simply, both the resistances are connected in series. So simply add them. You have 4 plus 2, 6 ohm as the answer. Okay. I hope you guys are following these methods very easily. You are able to solve the question along with me. Okay. Cool. Okay. Now the similar circuit, just with the battery being connected, and this time the question wants you to find out the potential drop across this 3 ohm resistance. Okay, so guys, if you remember, the equivalent resistance of these two came out to be 2 ohms, and we know that if we redraw this diagram, we will have the same current being flowing through 4 ohms and 2 ohms. So if I will be flowing through 4 ohms, it will be the same current flowing through 2 ohms. And say because of that, some V1 value of voltage gets dropped here. Okay, so can I say that across all the resistances, including 3 and 6, the voltage drop is going to be same? Means what? Because 3 and 6 are connected in parallel, so same value of potential gets dropped on 3 ohms and 6 ohm, and same value gets dropped on their equivalent, that is 2 ohm. So let's try to find out the value of the current first. I will be equal to V by R equivalent. V that is connected is 3 volts, okay, and R equivalent came out to be 6. So the current that is flowing is half ampere. Okay, so if I want to find out the value of V1, V1 is going to be I into this value of resistance, that is 2 IR. Okay, and same potential will drop on 3 ohms as well as on 6 ohms. So the current value is half. This is equivalent to, the value comes out to be 1 volts. Okay, if you are wondering that why this is not being found first to be the value of the current in these two branches, you can try that also. You will get that the value of current in this branch, the value of current say I1 will come out to be 1 by 3 ampere, and here it will come out to be 2 by 3 ampere. Okay, sorry, this will come out to be 1 by 6 ampere, so that you get the value of voltage as 1 volt only. Okay, because V will be equal to IR, so that will simply give you the value of the currents here. Okay, so the answer to this question, the same potential drop happening on 3 ohm, that is 1 volt, on 6 ohm, that is also 1 volt. So out of 3 volts, 1 volt is getting dropped in this part. So remaining 2 volt is getting dropped here, by the way. Okay, just the additional information. Okay, okay, moving on to this one. We have to find out the equivalent resistance between A and B again. So if you look at this, guys, let's try to simplify. Here, if you look at this branch, you can see that these two are connected in series. So 7 plus 5 is going to be 12. So what you are going to see, you are going to get that this 12 ohms and this 12 ohm that is coming as the equivalent of 7 and 5. By the way, this point is B. Let's call this point as C. So between B and C, these two are connected in parallel. And in parallel, if you have same resistance, the equivalent resistance will be R by 2. That means their equivalent is going to be 6 ohms. So if I draw from here, if I draw further, this is what I'm getting. I'm getting this as 6 ohm. This already was 4 ohms. Okay, and I have a 10 ohm here. This is point B, this is point A. Now look at these two, guys. These two are connected in series because the same current will go through 4 and 6. So in series, these two will become 10. So overall, very simply, this is how the equivalent diagram looks like. That this is 10 ohms, this is 10 ohms connected between A and B. So if you have same resistance connected in the two parallel branches, then the equivalent is R by 2. So that is 10 by 2. So your final answer is 5 ohms. That's your final answer. Okay guys, the equivalent resistance of the circuit is 5 ohms. Okay. Okay, now this is a very interesting case. We have to find out the equivalent resistance between A and B, and this is where you are going to connect the battery between A and B. Okay, have a look at it closely. Try to analyze what else do you think this circuit could be rearranged as. Hmm? Any luck, guys? What do you think? So, if you are thinking in the right direction, let me say that this point is P and this point is Q. Okay, and this point is going to be A obviously, and this is going to be B. So if I flip this triangle PAQ that you see, if I flip it like envelope opening, this is how it should look like to you. You see that? Let me just label it as well. This is P and this is Q. Let me show it to you. You see that, guys? See that? I've just flipped it. I have not done anything. I've not changed anything in the circuit. I've just flipped it over. Okay, and you know that current electricity says that current is a scalar quantity. So it doesn't matter how the wires are put. The current is same flowing through this diagram and this diagram. Now tell me, what does it remind you of? Hmm? Does it remind you of something called as Wheatstone bridge? Let's check. 2 by 2 is equal to 2 by 2. That means what? This branch is going to get useless and you will have these two connected in series. Yes, 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 I know you guys got it now, and these two are in series. So overall, the simplistic diagram looks like this. The upper branch 2 and 2 become 4 ohm and lower branch 2 and 2 become 4 ohm in series. And this is your point A and B, and 4 and 4 in parallel will become simply 2 ohms. Okay, I know now you are able to solve such questions on the tip of your fingers only. Okay, cool, awesome. Now this one, guys. Now this is actually not very challenging but looks like something complicated. So let me tell you how to simplify this. Okay, we have to find out equivalent resistance. So whenever you are moving on a line on a wire and no element, circuit element is coming in between, then the potential and the point will remain same. Like from this point to this, nothing came, no battery, no resistance, no capacitor. So points will remain the same. We did something similar in capacitance also, right? And if I move over this upper branch and I reach here, this point is also going to be A because nothing came in between. Okay. Similarly, if I move from B towards left, this is B, and if I move in this lower branch and reach to this point, I reach to point B. Now see that first resistance of 1 ohm is connected between A and B. This 3 ohm is connected between A and B, and 6 ohm is connected between A and B. So if I draw the two dots as A and B, then what is happening? I have three resistances which are connected between A and B. So they are connected across the same potential difference. So this is how your equivalent diagram looks like. So if I want to find out the equivalent resistance, so I'll have to now go by the reciprocal approach only because there are more than two resistances. So 1 upon 1 plus 1 upon 3 plus 1 upon 6, which says that the LCM is going to be 6. And for that to happen, this will be 1, this will be 2, and this will be, sorry, this will be 6, this will be 1, this will be 6, 2, and 1 overall. Yeah, got confused. Okay. So this tells you that numerator is 9, denominator is 6, and this is 1 upon RAB, by the way. So what do you say? RAB will be 6 by 9. As I told you, in parallel, the equivalent resistance will be smaller than the smallest resistance. The smallest resistance is 1 ohm, so your answer is definitely going to be less than 1 ohm. And this tells you that the answer is going to be 2 by 3 ohms, which is somewhere close to 0.66 ohms less than 1. Okay, cool. Okay, now an infinite ladder of resistance, something that we saw in capacitance earlier. So whenever we are trying to find out the equivalent resistance for a ladder, say if you consider a point P here and Q here. So if you remove the part before P and Q, the circuit still gives you the same value of resistance. So if I say that between A and B, the resistance is going to be X, then between P and Q also the resistance is going to be X. So after this, everything after this is basically X resistance. So if you redraw this, this is how we redraw the circuit. Okay, so this is point A, this is point B, this is 1 ohm, this is 2 ohm, and this is the part where P and Q are existing. Yes or no? This is P, this is Q. But the equivalent resistance between P and Q is also X. So if you go by looking at this, you can see that 2 and X are connected in parallel, and we can say that RAB, which we are interested in, is going to be equivalent to the resistance 1 ohm being in series with these two parallel combination, which is R1 R2 upon R1 plus R2. And the funny and interesting part is the equivalent resistance between A and B is also equal to X. So take the LCM, you have 2 plus X plus 2X, and this 2 plus X goes to the right hand side, gets multiplied with X. So this is how this simplifies. So I have 2 plus 3x equal to 2x plus x square, or you simplify it to make a quadratic equation, that is x square. This comes here, so minus x minus 2 equal to 0. Okay, now you guys have already studied quadratic equation, you know how to find the roots. Simplify it to get the value of x as 2 ohms. Okay, that's what your answer is going to be. You can put the value of x as 2 also to check it. Okay, so 2 to the 4, 4 minus 2 is 2, and 2 minus 2 is going to be 0. Okay, awesome. Now this one, guys, we have to find out the current that is drawn from the battery over here. So the battery which is connected over here, I'm assuming it's going to be something here like this. Okay, okay, I think this is supposed to be 15 volts. Some corrections needed here. Let me do that correction for all of you first. Okay, okay guys, so this is going to be where my battery is getting connected, and this is not 15 ohms, this is 15 volts of the battery. Okay, now let's try to simplify this. Okay, don't worry, in the session PDF you will have the corrections being made. So what you see here, that these three resistances appear to be connected in series. So 10 plus 1, 11, 11 plus 7 is 18, and 18 and 6 are connected in parallel. So if I go by that, 18 into 6 upon 18 plus 6, it gives me 6 4s are 24. So I have 9 by 2 ohms as the equivalent of this entire part. Okay, that means if I try to redraw this to simply look like a circuit which we all are familiar with, this is how the circuit looks like. Okay, this is 0.5, this is 8, this is 4.5, and this one is 2, and this is 15 volts. Okay, so if you look at our equivalent now, guys, all of these are connected in series because the same current that will start from the battery will go through all the resistances. So 8 plus 2 is 10, 10 plus 4.5 is 14.5, and this will make it 15 ohms, and the battery voltage is 15 volts. That means the current which was asked will be equal to V by R equivalent. That means 15 by 15. So the current comes out to be very simply 1 ampere. Okay, cool. What we did, 7 plus 1 plus 10, 18. 18 and 6 are connected in parallel, means you can see 18 here, 6 here. Their equivalent came out to be 4.5. We put it here. Then 4.5, 0.5 is 5. 5 and 2 is 7. 7 plus 8 is 15. That's what we get as the equivalent resistance. Okay. Yep. Now this one, guys, again the same logic, will try to find out the value of the current supplied. For that we'll require to find out the equivalent resistance, and to do that, let me define the points. If this is A, moving here, this will also be A. Let's call this point as C and this as B. So battery is connected between A and B. So this is A, this is B, and say somewhere in between is point C. So first resistance is between A and C, second is also between A and C. So these two are connected in parallel. Okay, so what do I have is 2 ohm and 6 ohm between A and C, and between C and B I have a 1.5 ohm. Okay, and between A and B I have 3 ohm. So let's do this. This is how the equivalent or other simplified circuit looks like. Okay, so what you see here, that 2 and 6 are connected in parallel. So 2 into 6 upon 2 plus 6 makes it 3 by 2 or 1.5. So you basically have two resistances between A and B which are 1.5 and connected in the same branch, and you have a 3 connected in a parallel branch. So overall, now you can see these two are going to be added in series. So what you have is 3 and 3 in parallel, and overall RAB comes out to be 3 by 2. Okay, and if I want to find out I will be equal to V by RAB. Okay, which means it's going to be 6 volt divided by 3 by 2, or simply 12 by 3. So the current comes out to be 4 amperes. Okay, that means answer is option A. Okay. Okay, now this one, guys, in this we have, this is by the way is a JEE 2020 question, and in this we have to find out the value of the current that is flowing in the 1 ohm resistance here. So in order to do that, we'll try to find out how much amount of potential drop is happening in the parallel combination here. For that, let's find out the equivalent resistance. Let's do it quickly here. So 2 and 2 are connected in parallel, so equivalent will be 1 by 2. 1 by 2 and 2 are connected in series. Okay, means zero point 0.5. 1 by 2 is 0.5. 0.5 and 2 is 2.5. 2.5 will have the same value of potential drop. Okay, this branch, which is 2 and zero point 0.5, it will have the same potential drop as the lower branch, and that is 1 volt. Okay, so 1 volt is getting dropped over here. Okay, and if I want to find out how much is the current flowing in this upper branch, say I will be equal to V by R. So that is 1 volt dropping on 2.5, or you can say I will be equal to 2 by 5 ampere. Okay. Now same current is going to go in the equivalent of this, that is 0.5. So let's find out how much is the potential drop that is happening here. Okay. So if I find out V1, then I'll be able to find out the value of this current. Okay. And just for our understanding, let's keep the current as I dash here. So I get the value of V1. V1 is going to be I dash into 0.5, that is 2 by 5 into 1 by 2. So V1 comes out to be 1 by 5 volts. So what I've got is the value of the potential that is getting dropped on this resistance. So on this resistance of 1 ohm, what I got to know that if I current is flowing, some V1 potential drop is happening. So I can find out I value as V1 by 1 ohm. So how much is V1? V1 is 1 by 5 volts and resistance is 1 ohms. So the value of current is 1 by 5, which is nothing but 0.2 amperes. Okay, that means option A is the correct answer. Okay, so a good question, and I've did it exactly in the same speed and with the same intensity as you should be taking it in your actual JEE examination. Okay, cool, guys. Now your time for your homework question here. Have a look at the question. Okay, so you have to find out the resistance between two junctions. Sorry, the junction resistance is given as R. You have to find out the equivalent resistance across A and B. So this is where the battery is going to get connected. Okay, so solve this question and do tell me what's the answer that you are getting, which option you think is correct. Tell me that in the comment section of this video. Okay, cool, guys. And if you want to solve more questions, I have done this video earlier, which is one shot revision of current electricity. If you're interested, you can go on our Vedantu's channel and look for this video and solve more questions from referring this particular video. Okay, and if you want, if you're a student of 2021 aspirant, then if you want to cover up the topics which I have done before this, okay, if you want to cover the topics that I've done before this, then in the channel playlist, you will find out all the lectures in this particular video, in this particular playlist. Okay, so look for 2021. So all the topics of electrostatics and before this, the current electricity one, you will be able to find out in this playlist. Okay, cool. Also, as a source of inspiration, guys, let me tell you the Vedantu's results last year, 2019. We had Rajdeep, Chirag Jain, and Sumit making it to the top, under top 50 ranks. Okay, these guys are currently studying in IIT because they cracked all India rank 38, 41, and 3 in the previous years of JEE Advanced. Okay, so if you think that it's difficult to study from home, then do look at these guys and take it as a source of inspiration. And to add to that, if you want to prepare even for, especially for guys who are aspiring for JEE 2020, your exam is happening just around the corner. It is in the month of July. We have a crash course, and the last batch is starting on 15th of June. Okay, where you are getting 90 plus live sessions, a lot of tests, more than 20 tests will be conducted. Your own performance analysis will be shared with you. Okay, so these 90 plus tests, 90 plus lectures, a lot of tests, your own performance analysis, rank booster quizzes, and a lot many things are there up for grab. And the batch is starting on 15th of June. Okay, so if you are interested in that, then all you have to do is go on the description box. You will find out the link in the description box for crash course and use this coupon code SMCC, because the crash course, which is worth rupees 25,000, could be yours for just under 4,000 rupees. Okay, guys. So I hope it is understandable to everyone. Remember, you have to use this coupon code, that is SMCC. Okay. Okay. Also, if you are interested in joining our Telegram group where we share assignment solutions, study material, and daily update, that link is also available in the description of this video. So do take that also, and come on our Telegram channel, and we'll interact together. Okay. So guys, this brings us to the end of this awesome series and parallel combination session. Okay, if you enjoyed studying this with me, then do press the like button, share with your friends, and subscribe to the channel. Also, press the bell icon so that you get the notification whenever your Suri sir is coming live. Okay, so guys, on that note, I'll take your leave and I'll see you very soon. Till then, take care, enjoy physics, and more importantly, stay safe. Bye bye.